Okay, welcome to today's class. For today, I'll help you solve question 4 of your tutorial sheet for chemical kinetics. So before I start, just ensure that you subscribe to this channel so that whenever I post something, you'll be notified or updated. So let's start. So what's the question saying? So the question is saying, consider the table of initial rate for the reaction between hemoglobin and carbon monoxide. So here we don't have the products because rate law shows how rate depends on the concentration of what? Reactants, not the water, the products. And then here we have been given this table which is summarizing everything. As you can see, we are having 3 experiments here. And in these 3 experiments, we can see that the concentrations for hemoglobin and carbon monoxide have been given like this. And in these same 3 experiments, the initial rate was what? Determined for all the 3 what? Experiment like that. And then the question is saying, A is saying order with respect to hemoglobin. So here on A, we are asked to determine the order with respect to hemoglobin. So how can we determine the order with respect to hemoglobin? So the first thing, we must come up with our solutions, and then here we need to come up with the general form of the rate law for this same water reaction. That's the first thing you're supposed to do. And then so here rate is equal to, you need to write rate constant K, and then you need to write the concentrations of the water reactants. So here the reactants you're having is what? Hemoglobin, and also having carbon monoxide like that. And then this must be raised to the orders X and what? Y, like that. So that's how you're supposed to do it. So here you need to write X and then there Y. And then here we need to determine this what? X, like that. And then so how can we now determine the order with respect to hemoglobin? We need to find this X. That's the one we want. That's the order with respect to this hemoglobin. So here we're going to use rate 1. So we're going to use this table. We're going to use experiment 1 and experiment what? 2 in order for us to find the order what? X. So let's start now. So here we're going to say let 2 over let 1 is equal to, then here you just have to maintain the general form of the rate law. Then you raise it to power X, carbon monoxide like that, you raise it to the order Y, and then here you just have to maintain the rate like that. Then there you're having carbon monoxide like that, then you raise it to Y like that. And then here you need to use now the information in the table given. So here your rate 2, have you seen what rate 2 is? So your rate 2 you're having 1.24, then you just have to substitute. So rate 2, that is 1.24 like that, is equal to, you write your K, and then what's your concentration of hemoglobin on rate 2? That's 4.2, so 4.42 like that. And then you raise it to power X like that. And then what's the concentration for carbon monoxide? So that's 1.00, and you raise it to the order Y. And then you say over, even this side you say over like that. And then what's your rate 1? Your rate 1 is given there, which is 0.6, so that is 0.619 like that. And then you write your K, and then what's your concentration for hemoglobin on experiment 1? So that is 2.21 like that, and then you raise it to X like that. And then what's your concentration for carbon monoxide on experiment 1? So that is 1.00, raise it to power Y like that. And then here what do you do? So you start dividing. So 1.24 divided by 0.618, that's going to give you, so there you're going to get 2, then you say is equal to, and then here this is common and this is common, so you cancel just like that. And then 4.42 divided by 2.21, it's going to, you're going to get what? 2. And then don't forget there is a power X. So here let me write it somewhere here. So you're having that, we are having X, and then here what do? You say you equate the powers, which means this one is having 1, Therefore your x is equal to 1, like that. Since you're having the bases are the same, 2 2, you equate the powers. So your order with respect to uh, the order with respect to this hemoglobin concentration is what? 1. So therefore you can say order for hemoglobin is equal to what? Is 1. So that's your answer. That's your answer for the first part. So we'll do the same thing on part B. So B is saying determine the order with respect to carbon what? Monoxide. So how can we find this? So we'll do the same thing. And then for this one, we use experiment 1 and what? 3. So we use 1 and 3. So for us to determine what? Y. So let me lab and then I create some space so that I do B. So for B, as I said, we're going to use experiment 1 and experiment 3 in order for us to determine this order Y. So B, so I'm going to use let, and then the experiment 3 over let experiment what? 1, like that. Then here we just have to maintain the chain law form of the let law, like that. Then you raise it to x, the order. Then here we write the concentration for carbon monoxide and then raise it to power y. That's the order. Then you just maintain like that, x, then this side carbon monoxide like that, raise it to power y. Then here what's your let 3? So let 3 here on the table we're having it to be 2.26, like that. And then our let 1 is what? That is 0.619, like that, is equal to, then k, like that. Then what's our concentration for hemoglobin on experiment 3? So that is 3.36, like that. You raise it to x, and then the concentration for carbon monoxide on experiment 3, that is 2.40, like that, and raise it power y, like that. And then down here the concentration for hemoglobin on experiment 1, that is 2.21, like that, the power x. Now this x we have already determined. We can even write to be 1 and 1 because we have already determined for x, if you can remember on the first part. Then for concentration for the concentration for carbon monoxide on experiment, that is 1.00, raise it to power y. Then so this we can cancel because we already determined. Our aim is to determine the order y. So here we just have to divide now. So what is 2.26 divided by 0.169? So you're going to get 2.4, like that, is equal to, then we have already cancelled that. And then here we divide 2.40 divided by 1.00, we're going to get 2.4 here as well. So we raise it to power y. Then the bases are the same. What do? You equate the power. So here which means is power 1. So therefore our y same as 1. So the order, so for B we are having order for order for carbon monoxide is what? 1 as well. So we have found for A and B. We are done for A and B. Now the question is saying C is saying so here we're supposed to determine the let law for this what? Reaction, the let law. So let law is very simple, provided that we have already found our orders. So we just have to replace in the general form of the let law. So the general form of the let law for this reaction is equal to, we're having that hemoglobin inside to power x like that, and then carbon monoxide raised to power y like that. And then the final answer, we have already determined the value of x and y. So our x is 1, so same as, even if even if you don't write anything there, it's same as 1. Even here it's same as 1. So just like that, then you're done. And then let me lab, and then I create some space for the last question for the value of the rate constant. So now let me solve for the rate constant. So here now d, so here you just have to write the rate law, the general rate law for this reaction, so that we can make our k, the rate constant k, the subject of what formula. So here our aim is to solve for this. How can you make that k the subject of the formula? How can you make this k the subject of the formula, which is the rate constant they want? So we are going to divide both sides by this concentration and that concentration, hemoglobin concentration and that, and then later on you're going to come up with this. So when you make the rate constant k the subject of the formula, you're going to have your equation to look like this, your expression to look like this, to look like this. So you're going to have your concentration for hemoglobin down here, and then you're going to have carbon monoxide down like that, and then here you just have to substitute. So here for the data, you can use if the information for maybe for experiment 1 if you want, or for the experiment 2 this information there. You can, if you use experiment 2, which means you're going to use this concentration 4.2 and this, and then for me I'm going to use the information for experiment 1 there. So on experiment 1, what are you having there? So your concentration for the rate for the rate is 0.619 like that, and then you can also include the units, that is more liter squared like that, over the concentration for hemoglobin, which is 2.21 mole per liter like that. And then we are having carbon monoxide, which is 1.00 like that, mole per liter like that. And then here, when you divide everything, when you work out on your calculator, you're going to when you divide everything, you multiply everything down, and then you divide, you're going to have your rate constant to be 0.28 liter per second like that. So that's the units, and you're done. As simple as that. So when you're having questions, just let me know, and then don't forget to subscribe, like, share, and comment, and thank you for watching.